So the general concept of stablecoins is that, Bitcoin, it's nice. You can send it all around the world, uncensorable, all the nice advantages, decentralized, all the nice advantages that we like about it. Big problem, it's volatile. If you as a merchant accept BTC, you have two choices. Number one, convert them straight into US dollars, pay a 1% fee, at which point there's not really much benefit. Or you can keep the Bitcoin and something might happen like what happened last month, and the Bitcoins drop in value by about 45% over the course of about a week. So the idea of stable coins that has sort of been circulating with some ideas from myself, some from Robert Sams, some from Dan Larimer and a couple of other people, is this idea of, can you create a currency that is sort of stabilized in price in some fashion? So can you, instead of taking Bitcoin's trade-off, where you say you have an absolute fixed supply, but then if demand is volatile, the price is going to be volatile, we say, can you try to fix the price so that if demand is volatile, supply will adjust up or down instead? So I guess we'll start off by letting everyone introduce themselves, because we're all involved in stablecoin related projects in some fashion. So Dominique, maybe you want to start off with the Decentralized Reserve Bank a bit?
Yeah. Shall I give a quick overview?
Sure.
Sure, okay. So I came into the Bitcoin space like everybody else, and I'd sort of first heard of cryptocurrency ideas back in 1998 through a thing called B-Money, which Wei Dai described. And I was interested, fell out of, got into other things, heard about Bitcoin, and thought, wow, this is going to be big, really huge. Peer-to-peer money is going to, and as a technologist, the first thing you think is, let's disintermediate the middleman, these horrible banks that, rip everyone off and give everyone such a bad time. And I think, a lot of people in the technology space made the same mistake, which is that they didn't really understand what money was specifically. Now, money is a unit of account, and it's also a medium of exchange. It's a technology for exchange, and it works better the more of a constant value it has. And I think everybody, to some extent, missed that. If you want to design the ultimate money, then it'll have ultimate stability. And that'll make your economy more effective and enable all kinds of other applications to be built on top of it more effectively. So then was the next step, how's this going to be done? How am I going to create a stable cryptocurrency? And I came across the Hayek Money paper by a guy called Ferdinando Amitrano, who's he wrote the QuantLib C++ library. He's like a senior quantitative analyst at IMI Bank. And then I started thinking about some dual currency schemes, came across a guy called Robert Sams. He had a similar scheme. And very quickly, a dual currency scheme has stablecoin and share coin on the same ledger. And the idea is that when you want to, as demand increases for your stablecoin, you increase the supply. And you do that by issuing new units of stablecoin to the pro rata to the holders of the share coins. And then if something happens and you have to contract the supply to support the price, what you do is you allow people to burn their stablecoins and receive these share coins at a discount to their market price, effectively. You create an arbitrage opportunity, so any kind of profit-driven trader out there can buy some stable coins from the market, pushing the price up, burn these stable coins, and get some share coins at a discount. Now, the problem with that system is that you have all these kind of feedback loops, right? So it's quite possible that there's a really bad event, lots of stable coins are coming back on the market, you really need to contract the supply dramatically. Consequently, you're going to have to issue a lot of shares, right? These stakeholder coins, in order to convince people to burn them. The market anticipates this, the value of the stakeholder coins then collapses, and the whole system just sort of falls apart and blows up. So there's this thing called the Decentralized Reserve Bank, which actually has three different kinds of coins. You have stable coins, stakeholder coins, and asset coins. And actually, when it expands the supply of stable coins, what it does is it gives 10% of the new stable coins to the owners of the stakeholder coins, and the remaining 90% of the new issue of stable coins is auctioned for asset coins. And asset coins are then held in reserve. What is an asset coin? For example, a bunch of people are working on these Bitcoin sidechains, right? So you can actually import Bitcoin onto your own ledger, right? And you can protect them by consensus. And you can actually hold these assets within your own ledger. And now, when you need to support the value of your stablecoin, you can tell people, look, you can buy stablecoin, burn it on the ledger at some ratio, and in exchange, you will receive Bitcoin. And in principle, this can be extended to any kind of asset that you can cryptographically describe. You know, it might be colored coins, if that can be done well. And that's the DRB. So it's a kind of decentralized version of central banking, but obviously much, much simpler, open, transparent, algorithmic, and so on.
Sorry, introducing ourselves or something. All right, I'm Chris. I'm with the Augur project. We're working on like a prediction market platform that's distributed and built on top of Ethereum. And I guess before I say more, I'll let Zach introduce himself.
Hi, I'm Zach. I'm working on a stablecoin proposal. It's a little bit different from his. It's got 3 core pieces. There's a contract for difference. There's an oracle to say what the price of US dollar is at the end. And there's a logarithmic market scoring rule so that there's always a price to enter into stablecoin or to leave it. And I'll give a brief description of what the contract for difference is. So everyone's got Bitcoin at first, and then there's 2 types of shares that are produced. There's the stable coins and there's the vol coins. And the stable coins maintain constant value with respect to the US dollar, and the vol coins take they kind of move opposite to the US dollar because they're holding all the risk.
So I guess one sort of economic issue here is that we've heard Zach referring to something called vol coins and Dominique referring to share coins, and these are actually the same thing. Vol coins are shares. So can you explain the economic argument for why a vol coin can sort of be considered to be a share of this kind of system?
I started with that same approach, but I abandoned it because the problem is that if people anticipate that there'll be downward price pressure on stablecoin and that volcoin, if you want to call it that, will be diluted, the market will anticipate that and therefore it'll be less useful for. So what I do is introduce assets that are held in reserve.
Right. So the general logic here is that you can. This is the economic model that Robert Sams came up with, which is that if you say, let's say I am going to maintain a strategy by which I will permanently maintain 1% of all vol coins. Now let's suppose that the current total amount of stable coins in the system is $1 million. Now let's say 10% more stable coins get issued. And so because of that, those stable coins are going to get issued in exchange for Volcoin. And so 10% of the Volcoins are going to be absorbed. And therefore because of that, if my strategy is to keep holding 1%, I'm able to sell off 10% of my Volcoins and it'll still be at 1% of the total supply. And so I'll be able to take a profit, and that profit basically is equal to 10% of the amount by which the stablecoin supply grows. Meanwhile, if the stablecoin supply shrinks, then the number of Volcoins increases, and therefore I'm actually going to have to purchase more Volcoins. And if I want to maintain 1% of all Volcoins, then the amount I'm going to have to purchase is going to be equal in value to 1% of the amounts by which the stablecoin supply shrinks. And so because of that, you can sort of mathematically prove that the economic value of a Volcoin is basically equal to the sort of discounted total future sum of increases and decreases of the stablecoin supply. And so the problem here, Dominique is pointing out, is, well, if, let's say, the current stablecoin supply is 7 billion, and then after that, people are suddenly realizing that, yeah, this particular instance of the system is not going to be used as much, and so the supply is never again going to be above, say, 4 billion. Then all of a sudden, the total value of the Volcoins is negative 3 billion, and so people sell them all, and so the system hyperinflates.
Yeah, that's right. And so people anticipate dilution to support the price of stablecoin because you're going to have to issue more units of the stakeholder coins in order to get people to burn their stablecoin. But as that happens, of course, the price, the market anticipates the dilution and the price falls. And the danger is that the market doesn't make an accurate calculation of what the correct floor should be, and it just keeps on falling all the way to zero. And of course, the further it falls, the greater the dilution is actually going to have to be. So you get this feedback loop. And so the only way to solve this, as far as I can see, is to actually hold cryptographic assets to defend the price, rather like a central bank does, which is interesting. So hence it's decentralized reserve bank. It actually holds assets in reserve, and it can use these assets. So to give you a practical example, if the stable coin supply grew to $100 billion, then 10% of that $100 billion would have been of the issue, new issue of stablecoin would have been given to the stakeholders, but the remaining 90% would have been auctioned for assets. Now, of course, you couldn't hold 900. Was it 100 billion or was it 90? I can't remember the example, but
100 billion, 10 billion, what is profit, 90 billion in reserve.
You couldn't hold reserves of 90 billion in Bitcoin yet, but there might be other kinds of asset, colored coins. Maybe it holds, sort of, mirror assets, gold, whatever.
So one sort of criticism that I will provide of that model is that if, in general, if you have a situation where all these different crypto assets are going in different directions, then it is not that difficult to generally insulate yourself against risk. You just have one of each of them. But what if we have the situation, which is the situation we've had over the past year, in which the value of all crypto assets drops by a factor of 3, and so you go from having a 90% reserve to having a 30% reserve?
Yeah, so I mean, obviously it's much better just to be able to hold crypto assets because you're just integrating with a decentralized network. There's no trust involved. So one of the things you can look at is things like I don't know, some kind of distributed file system like IPFS. When that has a coin, there's all these app coins that might be held in reserve, but. And the ultimate answer, and unfortunately, is probably that we need to hold, real-world assets through some kind of blinding mechanism, cryptographically. So, for example, you might hold, gold, Facebook shares, treasury bonds, whatever, in a trustless way, with some level of indirection inside the DRB. And there are actually sort of, I think, efforts underway or ideas about how that can be done. Yeah.
So one sort of idea in my design, actually, for stablecoins is that you have this system where if it turns out that the system has too much of a liability of one particular asset that it can handle by itself, then it charges an interest rate on it. And so the beauty of that mechanism is that you actually have an incentive to simultaneously hold, say, negative gold inside the system and positive gold in the real world. And then because there's an interest rate, your negative gold sort of decreases in negativeness, and that gives you a profit opportunity.
Yeah, I mean, this is kind of new to me, but I've heard ideas they use different mechanisms to achieve the same result. Yeah. So, like Nick Szarbo's looking at that kind of stuff, and yeah.
Especially for me, it's slightly contrarian. So I like Robert Sam's idea, but I know Isabella Kaminska from Financial Times did that nice debate with her. Just to look at her perspective, though, if you really are creating a central bank, and I'm not necessarily saying it's a bad idea. I'm saying how is that any better in your situation than say what the Fed's doing right now? Because we're only seeing like 2% inflation today.
Yeah. Okay. So the central banking system in the real world is
Well, I'm saying the U.S. I'm not
in the U.S. or anywhere is teetering sort of edifice of inefficiency and complexity and unknowableness. Private banks have fractional reserve systems. I mean, all these layers of bonds and other things. It's certainly not transparent. I mean, I don't know what the actual cost of real world fiat central banking, but it's obscene. And we're all paying for it. And it's also making a bunch of bankers rich at our expense. So the advantage of a decentralized reserve bank is that it's much simpler, it's transparent, anyone can examine these relatively simple algorithms and trade against it if they wish. It's predictable, and it's obviously very efficient. There aren't layers and layers of bureaucracy and the middlemen siphoning off our money.
Matt, question?
So, how would a decentralized reserve bank defend itself against speculative attacks like the Thai baht in the 1990s?
So my hearing is a bit funny at the moment.
How will the central bank fight against speculative attacks like what happened to the Thai baht in 1998?
Yeah, I remember there's been quite a few of these different. Well, so I mean, the DRB would have to hold reserves, and there are a number of ways. So. One of the attacks you can perform against any kind of system like this is to accumulate lots of stable coins and then dump them on the market. So there are two answers to how that's addressed. The first is that you seek lots of design features that make that harder. For example, you can reduce the sort of free cash, the M0 supply, by charging people a sort of demurrage for holding free coins, and give people interest using that revenue for locking their stable coins for some period of time. So that's one way. That reduces the amount of free stable coins that are available to perform that kind of attack. And there are lots of other kind of features like that you can introduce. The second part of the answer is that this thing has to hold substantial reserves. So if you imagine a cryptocurrency system, a stablecoin cryptocurrency system, which where the stablecoin has a $100 billion supply, and $90 billion in reserve are held in reserve. In addition to the value of the stakeholder coins, the actual value of the bank that can also be used for stabilization, you'd be a pretty brave trader to throw substantial resources at that, because unless you succeed in creating a run on the bank, you're going to lose badly. It's an all or nothing operation.
Contracts for difference are pretty simple for how they handle margin calls. If the price of Bitcoin were to drop a bunch, then the vol coins, there's not enough collateral there to cover the stable coins. So eventually there's a margin call, and if you're holding stable coin, they would just turn back into Bitcoin, and the vol coin are worth nothing at that point. So then you'd be exposed to any Bitcoin volatility from that point on.
Is value stability a well-defined notion? I mean, what if there wasn't a US dollar, and there was just we live in a dynamic society with a variety of goods and services, and like laptops were getting dramatically cheaper, other things were getting much more costly.
I'd say the CPI works pretty fine.
It's a good question. I mean, how do you define stability? Each stable coin is pegged against a basket of commodities, and it might be for a general purpose international currency that you choose a basket. You create a basket from stalwart currencies like the dollar, the pound, and the euro, and you may add in some other things like gold, designed to make it less inflationary. But you can also imagine a situation where you have very specialized fishing communities on small islands in the Pacific, where their cost of living is very much linked to the price of oil. They use diesel. The boats that do the fishing and earn them their income require diesel, and they run diesel generators to have electricity and so on. And they might choose to create their own stable coin where the basket it has a very heavy weighting for oil. So there is a level of subjectivity in it.
So what are your thoughts on sort of the existing set of stable coins like Nubits or BitUSD or Tether USD?
Well, I mean, all of these things have problems. So Tether obviously is backed by kind of people like myself on Bitfinex, because I'm a crypto trader. So I certainly wouldn't call, if we look at the history of cryptocurrency exchanges, there's rather an unfortunate record of mishaps. So, that's what's backing your Tether coins. If you go to Nubits, I mean, it's these guardians. They sell these things, and we're supposed to trust them to buy them back. I mean, it's not decentralized. It's not trustless. So, I mean, my view is none of them work. They're rubbish.
What is the point of the stablecoin if it's backed by commodities? Why not directly use this basket of commodities?
Because smart contracts cannot automatically control commodity units programmatically. Because smart contracts cannot control units of gold or oil or whatever programmatically. The whole point is to sort of because a piece of gold is like a brick that sits on a table. It's not like it's not.
But if this your stablecoin exactly has this basket of commodities, you could define.
Yeah, so I understand. Yeah, so the current problem is that it's not possible cryptographically to control, an ounce of gold, for example.
Sure, but this was the assumption that this could be.
Well, so in my case at the moment, the easy way of launching something like this, in the early days, is just to hold Bitcoin in reserve, because you can bring Bitcoin in via a sidechain. The problem is that doesn't scale very far. I mean, the current market cap of Bitcoin is like 2-3 billion, right? But there are people out there thinking about how to create kind of, mirror assets, like proxy assets, if you like, on the on some kind of blockchain. And when that happens, yeah, it may become possible to hold all kinds of asset cryptographically and securely. But there will always, in that case, be some point at which there's a link to the real world and some element of trust. But there are ways that can be addressed. It's beyond what I can describe here. But there are people working on that exact problem at the moment.
I guess the question is, if everything would be on the blockchain, if every asset, would we need money at all, or would we not directly always trade assets?
Possibly, yes. So one of the possibilities is that you actually have a wallet, and that wallet is composed from commodities. So what you do is when you look at your wallet, it'll give you a value in Bitcoin, and it'll give you a value in dollars, right? That's the total. But really, the wallet's composed from lots of different cryptocurrencies that represent commodities. And when you spend it, it's going through Bitcoin and being seamlessly translated into Bitcoin and then into whatever end form it needs to be to pay for something. So yeah, you're quite right. It could be that you don't even need stable currencies at all. What you actually need is these mirror assets, and people can compose their own. Yeah, exactly.
Yeah, so in Robert's paper, he mentioned to do purchasing power stability, not actually pegging to USD. He looked at using a shelling coin. He also looked at using two measures within the internal system, which was difficulty rating and I guess a TX volume, right? Right. So do you see there could be a third thing, or do you see any flaws? Like I know we talked about that on the list.
I did a blog post where I actually did some economic analysis on some of these sort of endogenous metrics. And what I found is that they can succeed at capturing maybe 50 to 75% of volatility. And to be fair, 50 to 75% of volatility actually could be good enough, because logarithmically speaking, the amount of the sort of volatility that gold has had over the past decade is a factor of 5. And if we take a quarter of that, then that goes down to about 1.5. And 1.5 is already roughly the volatility that many fiat currencies have against each other. So if you take things like difficulty, transaction volume, transaction fees, potentially even like build in other markets like file storage, you could do that. The one concern that I have remaining is basically exploitability. If you use very thin markets, then an attacker with a few $1,000s can like massively shift them. Yeah. Yes.
Central bank has a central bank policy. Would your central bank have it too? And then who I think is like part of it is like changing the discount rate, determining open market operations, and then who would do that? Is it an algorithm? And if so, yeah. Okay, so that's the first part of the question.
Yeah, it's a good question. I mean, the first point is, it would be transparent and open, and there would be an algorithm. But then, the question is, who creates the algorithm, right? And so obviously there's some kind of open source. Yeah, so there'd be some kind of software. I think in order for the algorithm to change, the network has to agree to adopt it, right? So one of the things that I think modern cryptocurrencies need to think about is what's the upgrade process? How do you efficiently push, revised and improved algorithms into the network? And that's one of the things that Bitcoin's had a problem with. But, the algorithm is fundamentally being created by the committers, whoever control that GitHub repo. And so you're right, people, it's the same with all centralized systems. There's a level of disingenuity, right? Everyone says this is decentralized, but there is a central control in the form of the software developers who design the protocols and so on, and possibly update them and coordinate the network and so on.
So also the central bank is a bank. It makes profit and it makes losses. So who does it belong to? Does it belong to the network? And does the whole network take the profits and the losses?
Basically. So once again, going back to Robert Sam's model, the model he pointed out is that basically the volatile coin itself is kind of simultaneously like a share in the system. So when the system takes a profit, what it does is it just immediately buys up as many vol coins as it can for that profit, and so the supply of the vol coin goes down. And if it takes a loss, then it just issues more vol coin. And then the theory is that the value of vol coin sort of ends up being kind of proportional to.
I think it's harder when you actually have assets in reserve, right? So if you have Bitcoin that you've brought in and you're now protecting by consensus, you've actually got exogenous, external assets that are held by this DAO, right? And I mean, who is the owner of these? So if you, let's say, going back to this example, that stablecoin supply has increased to 100 billion, and now you've got $90 billion worth of Bitcoin, assuming Bitcoin could supply $90 billion worth of Bitcoin. You've got $90 billion worth of Bitcoin held in this thing's reserves. Who owns these Bitcoin, right? I have no idea. I've thought about the problem myself. It's like not clear. Nobody owns it, right? There's this thing that just has them, right?
This might be a topic for the crypto law panel.
Yeah.
I didn't really get to describe like the way a stablecoin would work using a prediction market, but I'll probably do that when I present on like my actual like project. So, yeah, that's all I wanted to say.
Good.
Nope.
Okay. Thank you all. We'll be back here at 3:45.